Have you ever wished you could travel through time? Maybe you've found yourself daydreaming about what it would be like to visit a distant past, or to leap forward and see the wonders of the future. The idea of moving freely through the ages is something that has fascinated people for generations, sparking our curiosity and igniting our imagination. Imagine stepping into a machine and zooming back to see dinosaurs roam the earth. Picture the ground trembling beneath your feet as massive creatures thunder past, and the world looks nothing like the one you know today. Or maybe you'd want to witness the building of the pyramids, or meet legendary figures from history, seeing firsthand how the past truly unfolded. Or picture yourself rocketing millions of years into the future to witness humanity's advancements. What new technologies would shape our lives? Would cities stretch into the clouds, or would we be exploring distant planets? The possibilities are endless, and the future is a canvas for our wildest dreams. Time travel has captivated our imaginations for centuries. From the earliest stories told around campfires to the pages of classic novels and the silver screen, the concept of moving through time has inspired countless tales of adventure, mystery, and wonder. From ancient myths to modern science fiction, the allure of exploring the past and future continues to fascinate us. Ancient legends spoke of magical portals and enchanted objects that could bend time, while today's stories imagine high-tech devices and scientific breakthroughs that might one day make time travel possible. But is time travel just a fantasy, or could it be a real possibility hidden within the laws of physics? Scientists have long debated whether the fabric of time can be stretched, twisted, or even reversed. Theories like Einstein's relativity have shown us that time is far more flexible and mysterious than we once believed, opening up new questions about what might be possible. For generations, storytellers and dreamers have woven tales of time travel, transporting us to different eras and alternate realities. These stories let us imagine worlds where the impossible becomes possible, and where the boundaries of time are meant to be crossed. These stories tap into our deepest desires, to relive cherished moments, alter past mistakes, or catch a glimpse of what tomorrow holds. They remind us of the power of memory, the hope for second chances, and the excitement of the unknown future. But beyond the realm of fiction, scientists and physicists have been grappling with the nature of time itself, trying to unravel its secrets, and determine if manipulating its fabric is truly within our reach. As we continue to explore the mysteries of the universe, the dream of time travel remains alive, fueling our curiosity, inspiring new discoveries, and reminding us that the past, present, and future are more connected than we ever imagined. We often think of time as a straight line, a constant flow from past to present to future. It's something we measure with clocks and calendars, a steady tick-tock that marks the moments of our lives. But is time really as simple and predictable as it seems? For centuries, people believed that time marched forward at the same pace for everyone, everywhere. It was seen as an invisible ruler, measuring out the universe in equal segments, never changing, never bending. But what if time is not so rigid? What if it's more like a river, bending and flowing at different speeds depending on where you are? Imagine standing on the bank of a river, watching the water twist and turn, sometimes rushing, sometimes slowing. Time, too, can speed up or slow down depending on the circumstances. This idea challenges everything we thought we knew about the nature of reality. This is where the brilliant mind of Albert Einstein revolutionized our understanding of time. Einstein wasn't just a genius in mathematics and physics, he was a visionary who dared to question the most basic assumptions about the universe. His curiosity led him to explore the mysteries of time and space in ways no one had before. Einstein's theory of relativity, presented in the early 20th century, shattered our classical view of time as an unwavering constant. Before Einstein, scientists like Newton believed that time was absolute, ticking away the same for everyone. But Einstein's equations told a different story, one that would forever change our understanding of the cosmos. He revealed that time is not absolute but rather relative, intertwined with space in a dynamic cosmic dance. Space and time are woven together into a single fabric called space-time, and the way we experience time depends on how we move through this fabric and what's around us. Imagine a giant flexible sheet. This sheet represents space-time, the fabric of our universe. Just as a sheet can be stretched, twisted, or curved, so too can space-time be shaped by the things within it. Massive objects like planets and stars create curves in this fabric, much like placing a bowling ball on a trampoline. The heavier the object, the deeper the curve it creates, and the more it distorts the flow of time around it. Einstein showed that time is affected by gravity. Time slows down near massive objects. The stronger the gravity, the slower time moves compared to places with weaker gravity. This phenomenon, known as time dilation, means that time passes slightly slower at sea level than on a mountaintop because you are closer to Earth's mass. It's a tiny difference, but it's real, and it's been measured with incredibly precise clocks. So the next time you look at a clock on the wall, remember, it's not just marking the passage of time, but reflecting the strange, flexible nature of the universe itself. While the time difference between a mountaintop and sea level is minuscule, it's a fascinating demonstration of how time isn't as absolute as we once believed. Even the simple act of climbing a mountain means you're ever so slightly outpacing the clocks ticking away at sea level. This effect, though tiny, is a real-world example of Einstein's theory of relativity in action, showing us that time can flow at different rates depending on where you are and how fast you're moving. But if we look beyond our planet, we can observe even more significant time dilation in space. The vast distances, high speeds, and weaker gravity experienced by astronauts create conditions where the effects of relativity become much more pronounced. Astronauts aboard the International Space Station, orbiting Earth at roughly 28,000 kilometers per hour, experience time just a bit slower than people on the ground. Every day, as they circle the planet about 16 times, their bodies are subject to both the high velocity and the slightly weaker gravity of low Earth orbit. These factors combine to make their experience of time subtly different from ours. This is not science fiction. It's a measurable effect of Einstein's theories. Scientists have confirmed these predictions with incredibly precise atomic clocks, both on Earth and in orbit, proving that time really does tick differently depending on your speed and altitude. Consider the remarkable journey of Sergei Krikalev, a Russian cosmonaut who spent over 803 days in space across 6 missions. His dedication and courage made him a legend in the world of space exploration, and his time in orbit offers a unique perspective on the nature of time itself. Due to the effects of time dilation, Krikalev actually aged about 0.02 seconds less than people on Earth during his space flights. While this difference is incredibly small, it's a real, measurable shift. His personal clock ran just a bit slower than those of his friends and family back home. Because of this fascinating consequence of his missions, he is often called the greatest time traveler. Krikalev's experience is a living example of how our universe works, and how the passage of time is not as fixed as it seems. While this might seem like a tiny amount, it proves that time travel to the future is a real phenomenon, albeit on a small scale. Every astronaut who ventures into space becomes a time traveler, returning to Earth just a fraction of a second younger than if they had stayed home. It's a reminder that the universe is full of wonders, and that even the flow of time can be bent by the forces of nature. Traveling to the future, even by a fraction of a second, is fascinating. But what about journeying to the past? This is where things get even more complex and theoretical. One intriguing concept is the wormhole, a hypothetical tunnel that connects 2 distant points in space-time. Imagine folding a piece of paper in half and poking a hole through it. This hole acts as a shortcut, connecting 2 distant points on the paper. Wormholes are thought to function similarly, creating shortcuts through the vast expanse of space-time, potentially allowing for travel across immense distances or even backward in time. However, wormholes remain purely theoretical. Their existence has not been proven, and even if they do exist, the technology required to create and navigate them is far beyond our current capabilities. Another mind-boggling concept in the realm of time travel is the closed time-like curve, often depicted as a time loop. Imagine for a moment a path through space-time that loops back on itself, allowing travelers to revisit events in their own past. This concept actually arises from Einstein's equations, suggesting that time travel to the past might be possible under specific circumstances. However, closed time-like curves present numerous paradoxes and challenges. If time travel to the past were possible, it could disrupt the very fabric of cause and effect, potentially altering the present and future in unpredictable ways. The idea of time loops really raises profound questions about free will and the nature of reality itself. One of the most famous thought experiments illustrating the complexities of time travel is the grandfather paradox. Imagine you travel back in time to a point before your grandparents met. If you were to prevent their meeting, perhaps by accident, it would mean you would never have been born. But if you were never born, you wouldn't have existed to travel back in time in the first place. This paradox highlights the potential contradictions and inconsistencies that could arise from altering the past. It suggests that there might be inherent safeguards within the laws of physics that prevent such paradoxes from occurring, maybe by limiting our ability to change past events in a way that contradicts the present. So where does all this leave us? Is time travel the stuff of dreams, or could it one day become a reality? The answer, as with many things in science, is complex and still unfolding. Einstein's theories provide a framework for understanding the nature of time, and they don't entirely rule out the possibility of time travel. However, the scientific community is divided on whether time travel, particularly to the past, will ever be achievable. Some scientists believe that the laws of physics might inherently prevent time travel to the past, citing paradoxes and the potential for causality violations. Others remain more optimistic, suggesting that our understanding of the universe is still incomplete, and future discoveries might reveal ways to manipulate time in ways we can't yet imagine. While building a time machine might seem like a distant dream, the pursuit of understanding time travel really pushes the boundaries of our scientific knowledge. By exploring these concepts, we delve into the fundamental nature of the universe, questioning our place in the grand tapestry of space-time. The quest to unravel the mysteries of time travel encourages us to think critically, imagine the impossible, and explore the vast possibilities that lie beyond the horizon of our current understanding. Perhaps one day, what we perceive as science fiction today will transform into the scientific realities of tomorrow. If time travel were to become a reality, it would undoubtedly be one of the most profound discoveries in human history. It would fundamentally change our understanding of the universe and our place within it. But it also raises profound ethical and philosophical questions. Would we use this power responsibly? What impact would it have on our present and future? These questions are not merely for scientists but for all of us to ponder. The journey of exploring time travel is as much about understanding ourselves and our place in the cosmos as it is about unraveling the secrets of the universe. So I leave you with this. If time travel